Okay, this is for project 2, and I'm here to show the vector distance algorithm. So here is the main code for starting the server. This is just stuff about creating the server, and then this creates a datagram socket to retrieve datagrams. So here we have a byte array for receiving the datagram. And this is if it's an update datagram, and then here is what we want, the periodic routing table update. So here from the datagram, we grab the port and the ID so we can find out the server ID of it. And from there, we make sure that that when it sends its routing table, it is in sending itself, and we make sure that the routing table is in infinity. So I have -1 to stand for infinity. So if it's -1, we don't want it because that means that it can't reach that server. And then we also want to make sure um, that it's not that it's not the server that I'm currently. So if server 3 sends me a message and it sends the update for server 1 and I'm server 1, I don't want to care about it because I already know the distance between server 1 and server 3. Um, so if both of those are false, I have them both checked as false. If they're both false, then it starts looping through the routing table and checks to see if the server IDs match. And if they do, it calculates the cost. So it calculates the current cost to the router that sent the message. So if I'm server 1 and server 3 sends the message, I calculate the cost to server 3, and then I add the cost of the server that's talking about. So if it's sending me server 4's information. So I'm going to grab that cost. So it's the cost from server 1 to server 3, and then from the message, the cost to server 4. And I check if my current cost to server 4 is less than that new calculated cost that was just above here, or if it's currently -1, which is infinity, which means I can't reach that server right now. So if either of those are true, I update our on the routing table the next node, which if I need to jump to a different server node, I can to get to the most cost efficient path. It keeps track of it in here, and then I update the cost, and then I say which server I received the message from, and then I make receive empty for the new datagrams that will arrive. And so here, I'm going to start setting up my service. So I initialize what port number I want it on, and I pass it with the server command, the file plus how many seconds I want every update to be. And so I have this, so you know which file it is and what server number I currently am. So here we go. 422. There you go. So we have all 4 servers set up, and I'm going to do display on all of them. So you can see that they are all currently different right now. Um, so here you can see server 1 costs 0 to send to itself, and it can currently reach every other node. Server 2 right here cannot reach server 4, that's why it's set to infinity. Server 3 can reach everything, and server 4 looks like it can reach everything. And it looks like before I hit display, it did receive a message from server 1. So that's why server 2 is like that right now. So if it goes from server 2 to server 1, it costs 12. If we do display again, you can see that it received a message from server 3 and it updated its routing table as it costs less to hop to server 3. This is currently server 4, so it costs less to hop to server 3 to server 2, and it only costs 5. And if we do display here, yeah, same thing. It only costs 5 from, we're currently server 2 here. Only costs 5 to go from server 3 to server 4. And so right here we have received what, 3 packets. So we can check that with the packets update here. As you can see, I've actually got 4 before I called that. So received 4, and if I do it again, you can see it has reset itself to 0. If I do it one more time, you can see that I received 1 from message 3. So the packets is working. And so step sends sends out the routing update automatically. So if we just do packets right here, you can see it's gone 4, and I'm going to do step right now, and it sends out yeah, so it sent out at the same time as the automatic one did. So if we do packets, you can see is 2, and I'll do it one more time to make sure it didn't send twice. Yeah, so message 1 got called one more time. As you can see, you can do it with packets. And so the last 2 things we need to do, actually we need to do an update. So if we want to change the cost, let's say we're server 1 right now, so it's server from 1 to 2, we want to make that 2. So if we do a display right here, you can see the new cost is 2. And it should be the same thing here. Yeah, so the cost to 1 is 2. Looks like, yeah, everything is the same. Server 3 also has it as 2 by already. Yeah, it doesn't look like anything else was affected by that. Perfect. And we can disable servers too. So if I go to server 3 and I want to disable 1, so currently 1, and I do display, you can see that it is infinity. So it no longer, it cuts off the direct connection between servers. So as you can see right there, yeah, server 3 is set to infinity. But something I did do is that it still can access that server through nodes. So as you can see, we got an update from 4. And so now I have to access server 3. I have to go through node 4, and it costs 8. And let's see, the same thing on server 3. Yeah, it has to go through 4 to be 8. So that's how that works. And then if I do crash, it crashes all the servers. And if I display all of these are set to infinity and -1.